Hi, everyone. We're going to talk a little bit about fractions and whole numbers. Now, I can't remember if we did this lesson in class. I don't actually think we did. I think we got right up to like a mid-chapter checkpoint on this fractions chapter, and then we stopped. So we're going to talk about fractions and whole numbers, but a lot of this should be pretty familiar to you for what we've talked about with fractions so far, okay? So I want you to think about a whole number can also have a fractional name. We've always said, since we started fractions, that any number over itself equals 1. So 2 over 2 would equal 1. 4 over 4, or 4/4, equals 1. So when we're using fractions on a number line, and we're trying to find fractions that equal whole numbers, we can use that to help us, okay? So on this number line, we have Steve ran 1 mile and Jenna ran 4/4 of a mile. Did Steve and Jenna run the same distance? So we're going to look at this number line and we're going to figure out if 1 and 4/4 are the same, because we want to know, did they run the same distance? Now, you guys probably know that 4/4, because it's the same, one number over itself equals to 1. But let's look at it on the number line too. We have 1/4, 2/4, 3/4, 4/4. So if I could write in my book, we always start at 0, so this is 0/4. 1/4. This guy would be, what do you think? 2/4. Here we're at 3/4, and here we would be at 4/4. And since 4/4 is the same part on this line as 1, they end at the same point. I would put a point here for 4/4 and for 1. I know that 4/4 and 1 are equal to each other, so Steve and Jenna ran the same or a different distance. What do you think? Tell somebody near you. Tell the floor. Tell the couch. Tell the table. I think they ran the same distance because 4/4 and 1 are equal. Okay? Let's look at it with a different denominator. Complete the number line, locate and draw points at 3/6, 6/6, and 1. So here's my number line. I'm broken up into sixths, 0/6, 6/6. So what are we going to fill in all here? Go ahead and think about it. 0, first one's going to be, tell somebody, 1/6. 2/6, 3/6, 4/6, 5/6. Trying to say that right, sixths. Okay, now I need to draw points at 3/6, 6/6, and 1/6. So my 3/6 I identified as right here. So I'm going to draw my point right there. I hope you can see my mouse cursor arrow thingy. 6/6. Well, it's already labeled there. 6/6. And the last thing I need to find is 1. Guess what? 1 is right there, the same thing. Are 3/6 and 1 equal? Well, 3/6 was right here, and 1 is all the way here. Are they equal? Do the points line up for 3/6 and 1? I don't think so. Talk to somebody about why you think they're not the same. I think that 3/6 ends at a completely different point than 1 does. I think that 6/6 is equal to 1 for a few different reasons. I know that any number over itself is equal to 1. I also know that I put a point on this number line and 6/6 and 1 were at the same spot. Okay, so that's how I know they're equal. All right, here comes the next part of this fractions related to whole numbers. I can have fractions that are greater than 1. Let me say that again, because up until now, talking about fractions, we have said that fractions are from 0 to 1. They're all the little things in between those whole numbers. Okay? Now, You can call other numbers fractions too, in between other numbers. Watch. Each shape is one whole. I like to call these basketballs. So each basketball is one whole. Write a whole number and a fraction greater than 1 for the parts that are shaded. So in blue, I know this says there are 2 holes. 1 basketball, 2 basketballs. Each hole is divided into, not so good at this camera, 4 parts. 1, 2, 3, 4. It's fourths. 1/4, 2/4, 3/4, 4/4. Look, I have another basketball. 1/4, 2/4, 3/4, 4/4. How many fourths are there all together in both basketballs? 1, 2, 3, 4, 5, 6, 7, 8. 2 whole basketballs, or 2, equals 8 fourths. Now this is gonna look weird because the numerator is bigger than the denominator, but a big clue, if the numerator is bigger than the denominator, it's a fraction that is more than 1. Think about that. If the numerator and the denominator were the same, it would have to be one whole, right? Because anything over itself is equal to 1. When you get bigger, so 4/4 is 1. When you get to 5/4, you know that 4/4 is 1, so you know that you're 1/4 bigger than a whole. Okay, the more you do this, the more it'll make sense. So here we counted them up, 8/4 equal parts are shaded. Okay, fraction bigger than 1. Here there are 3 holes. Each basketball is divided into how many parts? Well, you might look at that and say, it's not divided at all, Mrs. Savage. It's divided into 1 part, okay? 1 part. So the denominator is 1 because it's only in 1 piece. So I have 1 over 1. We don't say once. 2 holes over 1, 3 holes over 1. Each hole is divided into 1 equal part. There are 3 over 1 equal parts shaded. Here's another trick. I can't remember if we talked about this in school or not. Anything over 1 is equal to itself. So 3 over 1 is equal to 3. 5 over 1 is equal to 5. Sawyer over 1 equal to Sawyer, okay? Anything over 1 is equal to itself, okay? So we are going to kind of skip over some of these. Let's try this one before you do some of the practice. Each shape is 1 whole. Write a whole number and a fraction greater than 1 for the parts that are shaded. So your denominator is still always take 1 whole and how many parts it's divided into. Remember, denominator is down in the dirt. Sometimes when I click on these, it like lets me type on them. Oh, there, I got it to work that time. Okay, and it'll show me the picture up there. Each shape is 1 whole. Type a whole number and a fraction. Well, that denominator is whatever those pieces are broken into. And I know that's 1 circle broken into 2. So my denominator is going to be 2. And now I need to count how many 2s or how many halves there are. 1, 2, 3, 4, 5, 6, 7, 8. It's a lot easier to see when the picture is not like small and squished up like that. So my fraction greater than 1 here is 8 halves, because 1 of those is a half and you've got 8 of them. Or the whole number, how many whole basketballs are there? I see 1, 2, 3, 4. So because that's there, I don't know if that's gonna work. Okay, so that is 4 holes. 1, 2, 3, 4. Or my denominator is 2 because I break each of these into 2, and it's 1, 2, 3, 4, 5, 6, 7, 8. 8 halves. Now, I don't want this to go super long. I'm already close to 10 minutes. I want you to try and figure out, see if you can find a relationship. Whoa, what just happened? It jumped around on me. See if you can find a relationship between that fraction, 8 halves, and the whole number 4. Okay, talk to somebody about that. All right, guys, try to practice. We'll see how it goes. Okay, bye.